Hello, everyone. Okay, in this lecture, I'll continue the same section that I did yesterday, section 4.1. Um, so, uh, so before that, as I told you guys on the last lecture that I will start assigning the daily work. All right, so yeah, starting from this lecture, from today, I'll assign something during the lecture time. So I can assign that at any time. So you have to watch the whole lecture to see what I assign for that day. All right. So for today, well, you'll know it today. So I'll assign something during the lecture time. Maybe it could be in the middle of the lecture or in end of the lecture. It could be at any time. All right. So you have to watch the whole lecture. Okay. And the due for that work will be the same day. So for this one, it will be tonight. So basically the due will be the same day. Will be the same day, and it will be always be due 11:59 p.m. on that day. All right, and basically where are you going to submit your work? That's the thing, right? So where are you going to submit your work? You're going to submit your work, so when you go to the Blackboard, so you can click this course, and then yeah, right here. Oops. I don't know what, this one's not moving. Okay, I'm trying to move this thing. Okay, there you go. So you'll see this tab on your left. All right. So once you click the course, you'll see this tab on your course. So, and once you click here, you will see the section that you're submitting. So for this one, since I'm teaching, basically today I'll be teaching both 4.1 and 4.2, but both work you can submit here. All right, just submit your work here for today. For the next one, maybe for tomorrow, I will give you a lecture, full lecture on 4.2. So I will create that section tomorrow. But for today, you can just submit your work here. All right. So you'll see this maybe every day. If not, then probably at least 2 or 3 daily work, basically 2 or 3 quizzes every week, something like this quiz every week. All right. So you have to see the whole lecture to see whether I assign the work or not. Okay. All right. So let's start the lecture then. So, okay. So here, so this is 4.1. We're going to continue this. All right. So now here, okay, the first thing here we're going to see. Okay. So yesterday, I think we talked about, let's say, if we say this is our a partition point, or let's say this is a, we can also say this is a critical number. All right, so if this is a critical number, and let's say this is side is increasing or positive, this side is negative, decreasing, right? I talked about this yesterday. So if it is positive, basically if f prime of x is positive, then f of x is increasing, right? And if it is negative, it's decreasing like that, right? So I talked about that in yesterday's lecture, so please go back and watch that first if you haven't watched it. So this is increasing, this is decreasing, right? So this means if it is increasing, then like I said, if it is increasing, then the graph on this side from this, well, on this region, it will be like this, something like this. And after this point, it is decreasing. So it will be something like this, right? So that means this point right here, we said this is local maximum. And this point, you can find this point, since we know the x is c, then find f of c. So this whole point, this point now is called local maximum point. So whenever I ask you to find local maximum, then you have to find this point, all right? Do not just give me c. All right, so if f is given, if f is defined, and if I ask you to find local maximum, then you need to find this whole point, all right? Similarly, now if I say the same thing, now this side is negative, this side is positive, then this is decreasing. Let me just write dec, and this is increasing, inc. So that means the graph is, and this is the critical number, right? If it's decreasing, then it will be something like this. If it is increasing, it will be something like this. So this point is, again, this is local. Now this time it's local minimum. And again, you can find this point. We know C. And now we can find f of c from this point as well, right? Okay. Now, next one is, again, let's say this is C. And let's say this is increasing, this side, and also this side is increasing. So in this case, the graph would be something like this. It's increasing, and I guess it's increasing. All right, so, and this point right here is C, but here both of these are increasing. So in this case, we don't see any, well, this point is, we don't know if this is local maximum or minimum, because it's, the graph is increasing, right? So this point is not a local maximum or local minimum. All right, so same thing with the minus as well. So if there is a minus, again, if this C, or critical number, if this is a minus, this is a minus, the graph is something like this. It's decreasing, and let's say this is a C. Again, we can say the same thing. It's not a local minimum, maximum or minimum. And when we say a graph has local maximum, well, let me just write max, or local minimum. So this means you can also say, instead of saying local max or local min, you can also say local extrema. So if you see, if you see that, let's say, if you see anywhere that it says that a function has local extrema, then that means the function has either local maximum or local minimum. It could be anything. All right, so that's what the local extrema means. All right, so now let's do an example. So this is 6x squared. Okay, so now here we need to find a few things here. So first one, we need to find a critical number All right. The second one, I need to find a local maximum or local minimum. All right, and the third one, we need to sketch a graph of this function, labeling the local maximum and labeling local minimum point on the graph. So we need to sketch a graph of f. Okay, so now first we need to find critical number, right? So to find the critical number, we need to find the f prime of x, right? So f prime of x is equals to, so take the derivative of this whole thing. So first, when I take the derivative of this x to the power 3, this will be 3x squared minus this 2 will come down here. So it will be 12x, and 9x is basically x. The derivative of x is 1, so you just have 9, right? And then assume f prime of x is equals to 0, and then find the value of x from this. So here we have 3x squared minus 12x plus 9 is equals to 0. Then well, I can factor out 3 from all of these, right? So if I factor out 3, then I have x squared minus 4x plus 3 is equals to 0. Divide 3 on both sides, so this will be gone. All right, and we just have this. So now I can find the value of this. Well, this is also same as, since I have a 3 here, right? So I can use 3 and 1. So this will make x minus 1 and x minus 3. Because minus 1 minus 3 will make minus 4, right? Is equals to 0. So from here I get x is equals to 1 and x is equals to 3. So I can check like this. Well, we can easily see that these number exist. Well, when I use this number, both of these number, x here, we'll get some number, right? So this f of x exists when we say x are these two values. So that means I can say these two are. Oops. These two are critical numbers, right? So these are critical numbers. Okay. Now, after this, I can make a sign chart. Let me just do it here so I can see it. I can see everything on one page. So now, okay, 1, let's say it's there, 3 is somewhere down here. Now I need to find the local maximum or local minimum. So to find that, I need to know the reason, whether this reason is positive or negative. So I need to find all of these reasons are either positive or negative, right? So let's pick any point on this. So if I say x is 0, then plug in this x value to this equation, all right? To know whether this reason is positive or negative. Okay, so and also from there I can say whether this reason is increasing reason or decreasing reason. Okay, so now if I plug in this x to this equation, then f prime of 0 is, well, if this is 0, this whole thing is 0. If this is 0, the whole thing is 0, then I get positive 9, right? So this means this reason is positive. Similarly, you can pick any point, and this, you can pick 2, then I think you will get negative. You can try this on your own. And if I pick any point here, let's say if I pick 4, if x is 4, then this thing will be positive. All right, you can do this on your own as well. But this is not the assignment I'm asking you to submit. This is not the part of that. You can just do it for your own practice. But this is not what you need to submit. I will probably assign later on. Okay, so now, so this means this is increasing. This is decreasing. This is increasing, right? So I can say the increasing interval is from -infinity to 1, and also this reason, right? 3 to infinity. And the decreasing, or D, is this reason, right? 1 to 3. Okay, so now since we are trying to find local maximum or local minimum, now we have 2 points. So we need to figure out, well, whether this is maximum or minimum, or this is maximum minimum. But I know that this is increasing and this is decreasing. So here it will be, the graph will be something like this, right? So this point here, 1, is maximum, and here, well, the graph will be, since this is decreasing and it's increasing, so this point is minimum. So I know that 1 is maximum, 3 is minimum, but I need to find the exact point. So when x is 1, now this time I have to plug in this 1 to the original equation to find local minimum or maximum. All right, don't be confused in this. To find positive or negative, whether the function is increasing or decreasing, I plug in this to this, the derivative. But to find local maximum or minimum, I need to, well, since I know this point is a critical number, so I have to plug in this critical number to the original equation. So when you plug in that to the original equation, f of 1 is equals to, well, you can do this on your own. Again, this is not the assignment that I'm wanting you to submit. This is not a part of that. Okay, but you can again do this on your own, and if you plug in this to this, you'll get 5. Similarly, so I can say, as I said, this is a local maximum. So from here I can say 1, 5 is local maximum. Okay. Similarly, now I can, well, I know that this is local minimum point, but I need to find the exact point. So again, x is equals to 3. Then f of 3 is equals to, again, you can do this on your own, then you can go get 1. So from here I can say 3, 1 is local minimum, right? Now after this, well, now I need to find the graph, or I need to make a graph, or its case a graph. But before that, let me assign you the quiz problem that I want you to submit. Okay, so this is going to be a quiz problem that I want you to submit. So here, let's say a sign chart is given. Let's say there is A, B, and C. So minus, so this reason is minus, this reason is plus, this reason is also plus, this reason is minus. All right, now you need to find your job. So whenever you submit, make sure you also draw this picture, and then answer. Okay, you need to find the reason, or which reason is increasing and decreasing. So you need to write that like this. All right, so you need to write like this. You need to write the interval where it is decreasing or increasing. And the second one, you need to find local minimum and local maximum. Since here I haven't given you functions, there is just a line sign chart. So when you find a local maximum or minimum, in this case you don't have to find a point. Just tell me which point is maximum or minimum. If you think, okay, let's say if you think B is a maximum, then let's just say B is a max. Just say that. Or if you think B is a minimum, just say B is a minimum point. Okay. And for increasing and decreasing, you have to find the interval like this. Okay, so that's the quiz problem. That's the first problem. Okay, I might assign more problem in this lecture, so you keep watching the whole lecture videos. All right. Now, as I said, the third thing is you need to find the graph, right? So or find the graph of this f function. So the simple thing, or the thing that you learn on the, let's see, right? So the thing that you learn on the college algebra, just make x and f of x table. Just give some value of x. That way you can get the value of f of x, right? So if I say x is 0, if x is 0, then f of x is, well, so x is 0, then f of x is 1. Okay, just do that on your own to see if I've done correct. If x is 1, then you get 5. If x is 2, if x is 3, and if 4, then it will be something like this. Now, to graph this, just make f of x table. Oh, sorry, f of x graph, and then plot this point. So first one, it will be 0, 1, let's say somewhere down here. 1, 5, let's say 1, 2, 3, 4, 5 is, let's say 1, 5 is somewhere down here. 2, 3 is somewhere down here. 3, 1 is somewhere down here. And 4, 5, sorry, it's 4, 5. And 4, 5 is somewhere down here. All right, so just make a graph. So the graph would look something like this, right? So something like this, right? So now, as I said that, okay, this is 1, this is 3. As I said in the previous here, 1, 5 is local maximum, 3, 1 is local minimum. So you can just label that here in the graph. So this point is local max, and this point is local min. All right, so yeah, this one, it seems like there are a lot of things to do, but once you understand the idea here, or once you get used to with the idea, there is nothing hard here. All right, so just that you have to get used to with the idea. So if you're still confused, go back and watch this video one more time and do the Pearson homework. All right, even from there you'll get idea and try to, okay, one thing on the Pearson, try to do the Pearson homework without getting help. Well, you have an option to get help there, right? So try to do it without getting help first. If you think it's really hard, okay, if you feel like, okay, I can now solve this, then at that point you can get help. But first try to do on your own. So that way you can understand the problem more clearly, all right? Okay, so this is 4.1. Okay, now let's go to section 4.2. Again, 4.2, I will divide this section into two parts. I will talk a little bit from section 4.2 first, and I'll complete this on the next lecture, section 4.2. All right, so like I said, this is the quiz, all right, that you need to submit to the link I showed you on the Blackboard 4.1 quiz. Just submit it on that. Okay, so I'll be assigning more. All right, so keep watching the whole videos. Okay, now the second one is 4.2 concavity. So first we'll start with the concavity, and this one, okay, here's a few things we should know. Okay, here's the first one. Let's say now, and this section we'll be talking about the second derivative. Right, so if I say f double prime, okay, there is a 2 prime, so something like this. This means the second derivative. So if the second derivative of f function is greater than 0 on certain interval, let's say the interval is a comma b, then I can say f is, or if f double prime is positive, then I can say that f function will be concave. Concave upward. So which means the graph would be something like this. It's facing upwards, whatever you want to say. It's concave upward. Or maybe it will be something like this, or even maybe something like this. Okay, so this thing, these three graphs is concave upward graph. The same thing now again, if now f double prime is now less than 0 or negative number on the interval comma b, then we say that, okay, f is concave downward. So in this one, the graph will be something like this, or maybe like this, right? Okay, so here, since, well, this section is about second derivative, so there are different ways you can write the derivative, right? I've talked about that on, I don't know, maybe section 2, I don't know, 1, 2, maybe on 6. But anyway, let's say if we know y is equals to f of x, then I can find the first derivative of this. And the way you write the first derivative is, well, I can say f prime of x, or I can even write y prime, right? Because I have y is equals to f of x, or I can say d of, or dy over dx. So basically I'm taking the derivative of y in terms of x because I have x function here. Or I can even write d of f of x over dx. Okay, this is how you write the first derivative. The second derivative is pretty much similar thing. Okay, first here I write double prime, right? F double prime of x, or I can even write y double prime. So now for second derivative, I can also write d square y over dx square. All right. So this also means you're taking the second derivative of y in terms of x, and this too also means the second derivative, right? And d square of x over dx square. All right, so these are the different ways you can write the second derivative. Okay. Now, here we'll be talking about the inflection point now. So let's explain the inflection point from an example. Okay, so a function will be given. X cubed minus 9x squared plus 24x minus 10. All right, so I need to find the inflection point of this function. All right, so the way we find the inflection point is first we need to find the second derivative. Okay, and once you find the second derivative, I have to assume the second derivative of x is equals to 0, and you'll get some value of x. So that value will be the partition point. It's not an inflection point yet. And now you will choose some point on this side. You will put some point on this side. You'll plug in that value to f inverse of x. And if you get, let's say if you get this negative and this positive. So in this case, if one side is negative, if the other side is positive, then and only after that you can say, okay, this is the inflection point. Okay, so okay, first let's find the second derivative. So before we take the second derivative up, first I have to find the first derivative, and then only you can get the second derivative, right? So first derivative is 3x squared minus 18x plus 24, right? And the second derivative is now you need to take the derivative of the first derivative. The derivative of this first derivative is the second derivative, okay? So now the second derivative is now 6x minus 18, right? And then, okay, and then now say second derivative of x is equals to 0, then the second derivative is also 6x minus 18, and we still have h equals to 0. So from here, I move this to the other side, divide both sides by 6, so x is 3. Okay, so now this 3 is still not an inflection point. We don't know if this is an inflection point or not. So we need to find that whether this is inflection point or not. So this time, at this point, we just said this is a partition point. Okay, now pick any point on this region. Let's just say x is equals to 0, and then plug in this to the second derivative. Second derivative, 0 is equals to, so if x is 0, then this will be 0, so we'll just get negative 18, right? So that means this is a negative number. Similarly, pick any point on the right, let's say 4, then f double prime of 4 is equals to, so if this is 4, then 6 times 4 is 24. 24 minus 18 is 6, or a positive number, right? So that means this region is concave up, right? And this region is concave down. Sorry. This region is, sorry, if this is negative, then this is concave down. Right, so this region is concave down, because this is negative here, and this is concave up, sorry, yeah. Concave up. Okay, so say, okay, this is the inflection point. And the actual inflection point, we can again find the inflection point now using x is equals to 3. Actual point, I have to find, also I need to find f of 3. Since x is 3, so f of 3 means using this first equation, I can find f of 3, which will be 3q minus 9 times 3 square, right, plus 24 times 3 minus 10, right? So from here, okay, you can use a calculator and you will get 8. So that means 3,8 is the inflection point. Inflection point, or let me just write PT, inflection point, all right? So yeah, this is how you find the inflection point. Now, okay, now second problem. So let's say a sine chart is given. This is A, this is B, this is C. Okay, now let's say after you find the double prime, to find the double prime, then you'll get this region negative, you'll get this region negative, you'll get this region positive, and this region is negative. Now your job, okay, so again, when you answer this, draw this picture as well, and then answer again two things. So the first one, find concave down and concave up region, and then find the inflection point. So again, if you think, let's say if you think A is the inflection point, then just say A is the inflection point. And if you think, if you think, let's say if you think this is a concave up, all right, if you think this is concave up, then you have to write C comma positive 1. So this, so you have to say this is a concave up. If you think this is concave down, then you have to write this is concave down. I'm just showing the way you write. This is not the answer, all right? So you need to find the answer. Okay, so yeah, I assigned two things. This one, right? And another one was this. So, okay, so, and submit this by tonight, which is, so since I'm assigning this, so this is part of the Wednesday lecture. So yeah, the due will be the Wednesday. midnight. All right, Wednesday midnight, 11:59 p.m. All right. So yeah, this is it for this lecture. I'll see you in the next lecture. Thank you.